Hello, welcome to Maths with EJD. In this video, technically, this is a continuation of sequences and series, but I thought it wise to actually separate binomial theorem as a playlist. So what I'm going to do is that I'm going to have it separately as a binomial series as a playlist, right? But then I'm going to add it also to the sequences and series playlist so that I can just continue like that. So if you check the playlist already, I have some topics on sequences and series. Then I added power series, which was another playlist I had done before. So this binomial theorem will just continue that playlist. So just enjoy. Let's go. So here we are looking at binomial theorem, its overview, and how it is connected with Pascal's triangle. Okay. So first of all, what is the binomial theorem? That's where we start from. The binomial theorem. So just like how I like to explain it, right? So the word binomial. So you see, you have bi and you have nomial. So simply, bi means two, and nomial means terms or names or anything like that. So it means that we're talking about a theorem that involves two terms, okay? Two term, two terms are involved, basically. So let's talk about what that is about. The binomial theorem, the binomial theorem it allows us to expand any power, any power of a binomial expression. That is an expression having two terms. A binomial expression, that is an expression like a plus b raised to power n. So we can now do that into a sum. And that, you see that's where it now turns into like a series. So that expression can be expanded into a of terms, sum of terms involving powers of a and b. Okay. Now let's talk about the expanded form of that. So the expanded form, the expanded form is a plus b raised to power n, and that can now be expressed as summation from k equals zero. You see, this is now why it is a series. So and this is so we have this bracket this way, this n k, which is simply n combination k. We are going to break that apart. So and then this is a raised to power n minus k, b raised to power k. Very soon you see how this actually comes about. So now, what are the key terms here? So the key terms in that expression are as follows. First of all, you have n. N is actually the exponent of the binomial, the exponent of the binomial. Okay, that's the power. Then we have k. Of course, you already know a and b are the two terms, right? So k is the index, the term index, the term index. It is k that tells you maybe you are dealing with the first term, second term, and something like that. So the term index starting actually from zero, starting from zero. Okay. Then you have n combination k, which is really important. I think I should actually make a playlist on permutation and combination, or I think that's better under what is this thing called? This part of math that deals with counting combinatorics. Yeah, probably one of these days I will do something on combinatorics. So this is actually the binomial coefficient, the binomial coefficient calculated calculated as n combination k, and n combination k is actually, you can also write as n combination k, which is then equal to n factorial divided by k factorial into n minus k factorial. So this is really useful here. It's something very important on that combinatorics that is coming here. So then you see that each term in the expansion, each term in the expansion has a particular a, which is raised to power n minus k, and these are powers of a decreasing. So these are decreasing powers of a. Powers of a decreasing, and then you have b raised to power k, which talks about, so you have two terms. The first term is a, all right? The first term is a, the second term is b. So the power of a is decreasing while the powers of b are increasing. So here you have b raised to power k, which talks about the powers of b increasing. Of course, as we go on in this series, you'll understand better because we're going to break it apart as we move on. All right, now that that is done, let's move on to talk about Pascal's triangle, which is really crucial in this situation. You have Pascal's triangle. So it's really interesting. Now let's see the binomial coefficient. Now these coefficients now that this part actually gives us, that this end combination K gives us, can actually be generated by Pascal's triangle too. So the binomial coefficients in the expansion are directly linked. They are directly linked to Pascal's triangle. Now, the issue is, what is the Pascal's triangle? So let's see how to construct the Pascal's triangle. How to, okay, yeah, that's fine. How to construct Pascal's triangle. How exactly do we do that? Okay, let me go back to black now. So the first thing you do is start with 1 at the top. Start with 1 at the top. Okay. Then second thing you do is each number is the sum of the two numbers directly above it. Now you see what this means in a jiffy. 3, the nth row corresponds to the coefficients. The nth row corresponds to the coefficients in the expansion of a plus b raised to power n. Now, this is exactly what we mean by all of these things you have said now. Now, imagine, let's see some example rows now. So I'm still going to do this better, but let's start with this example rows. Imagine row 0. So for row 0, all you have is you have a plus b raised to power 0. And in that case, for Pascal's triangle, that is just 1 up here. You just have 1 here. Okay, let me even follow this pattern. So you have 1 here. And then next thing now is this. You have row 1. So for row 1, that's like when you have a plus b raised to power 1. So here now you see n is equal to 0 here. Here, n is equal to 1 because the power here is 1. Okay, maybe I should not do it this way because we may need to expand. So a plus b raised to power 1. If you break that down, that's actually 1a plus 1a. I mean 1a plus 1b, okay? Just exactly the way it is. But here, everything will just be 1. And that's why we have 1 here. So these two ones now will now just make this one to have to be. So it's more like you're dropping this one and you're dropping this one, okay? Then we go to row 3. So for row 2 now. For row 2, it's like you have a plus b raised to power 2. Normally, we know when you expand this, right, that's going to be 1a squared plus 2ab plus 1b squared. If you expand this, this is exactly what you get. Because, a squared is still the same thing as 1a squared. So what's going to happen is that next you have, so this one now, you drop it. So you drop this one. Then 1 plus 1 is 2, and you drop this 1. And you see that's 1, 2, 1, like this here. Then we go to row 3. So for row 3, so it's like you have a plus b raised to power 3. And what happens in that case? You have 1 a raised to power 3. Don't forget, the a will carry the highest power first, and it will be reducing, while b carries the smallest power, and it will be increasing. So the next will now be 3. Of course, if we expand it, this is what you're going to get. We are going to still do all these things in depth. So I'm just trying to establish what this is about now. So then next you have 3a squared b1. You see, a is reduced, the power of a is reducing, the power of b is increasing. Next you have 3 again, a raised to power 1, b raised to power 0. And lastly, you have 1, a raised to power 0, b raised to power 3. So what do you do next? So for the next row, you have this one now, drop it. Then 1 plus 2 is 3. Or better still, so drop this one, 1 plus 2, 3. So this 3 comes here, and then 2 plus 1 is also 3, and this one you can drop it, okay? And that is row 3. So next you have row 4. Okay, I mean, let me just even stop here, right? Let me stop here. Well, but or let me just do this. So for row 4 now, you're going to have a plus b raised to power 4. I don't want to bother with all this one. Well, I can bother. Yeah, let me bother. So I have a raised to power 4, b raised to power 0. What's the next thing now? The next thing will be 4, 4a raised to power. Because if you don't even know what the next thing is, then it's actually going to be something like this. This one now, drop it. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Then drop 1. So it means you have 1 a raised to power 4, b raised to power 0. Next, 4 a raised to power 3, b raised to power 1. Okay. Next, you have 6 a raised to power 2, b raised to power 2 also. Then plus next, 4a raised to power 1, b raised to power 3, plus 1 a raised to power 0, b raised to power 4. And that's why you have 1, 4, 6, 4, 1. So generally speaking, Pascal's triangle is something like this. Okay, Pascal's triangle is simply something like this. Imagine, so when you have a plus b raised to power 0, so it's everything is just 1. Then when you have raised to power 1, so 1, 1. So this one, drop it, 1, drop it. So it's like this is coming down, this is coming down. Next, you have, so if you have power 2, for this is row 0. For power 1, this is 1, 1. For power 2 now, so all you just need to do is this one, drop it. 1 plus 1 is 2. Then this one, drop it. So one drops, and here it's like everything. I mean, it's like adding these two together, you get this, okay? Basically. Then next, you have this one now, drop 1 plus 2, 3, 2 plus 1, 3. Then this one, drop it. Basically, that's row 3. Of course, row 0, row 1, row 2, row 3. Next, what do you do? This one, drop it. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then drop 1. Basically. Next, that is for row 4 now. That when you have something raised to power 4. I'll keep doing it until I don't have any space. So next, what do we have? This one, drop it. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is another 10. Then 4 plus 1 again. 4 plus 1 is 5. And then 1. Okay. So next thing is what? You drop okay, of course. Okay. Yeah. Next one, you drop 1. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. Then 5 plus 1, 6. And then drop 1. Okay. So we can go on. So this is when you have power 6. So this tells you the power 0, 1. I mean 0, 1, 2, 3, 4, 5, 6. So next, drop 1. 1 plus 6 is 7. 6 plus 5 is 21. 15 plus 30 is 35. 20 plus 15 is 35. Then 15 plus 6 is 21 again. 6 plus 1 is 7. And then drop 1. Okay? So we can go on. Let me see how far I can go. So 1 plus this, 8. 7 plus this is 28. This, 55. This, 70. This again, 50. Oh, this should be 56, actually, 56. Then this is also 56 because there's symmetry now. Then 21 plus 7, that's 28. 7 plus 1, that's 8. And then you drop 1. So let me go as far as 10. So number 9 now, power 9, because this is power 8. Power 9, you have 1. 1 plus 8, 9. 8 plus this is 36. 28 plus 56 now. 28 plus 56, that is 14, right? Yeah, 14. That's 84 in short. 84. Then here you have 126, I believe. Yeah. Then here again you have another 126. This plus this. Then next 56 plus 28 again is 84. This is 84. 28 plus 8 is 36. 8 plus 1 is 9. And then you drop 1. Then if you have power 10, 1. 1 plus 9, 10. 9 plus 36 is 45. 36 plus 84 is 120. Yeah, this is 120. 84 plus 126 again. 84 plus 126 should be 84 plus 126. This is 30. That's 930, I believe. Yeah, that should be 930. Because 126 plus 4 is 130. No, that can be not 930, sorry. 130, 126 plus 4 is 130. 130 plus 80 should be 210. Yeah, that's 210. That's actually 210. Then next, you have 126 plus 126. That's 252. Yeah, 252. Yes. Next is this again. 126 plus 84. So that's 130 plus 80, which is 210 again. And then 84 plus 36. 84 plus 36 is 120. 36 plus 9. No, don't forget all this. 36 plus 9 is 45. 36 plus 9 is 45. And 9 plus 1 is 10. Then drop 1. So you have 36 plus 9, 45. 9 plus 1, 10. Then drop 1. So that's if you have something up to power 10. Now, before we finish this video, let me use Pascal's triangle to do a very simple expansion. So now what do we let's try this example. Example, expand x plus 2 raised to power 3. So the power is 3. So what do we need? We have 1. That's row 0. Then this is row 1. Row 2 is 1, 2, 1. Row 3 is 1, 3, 3, 1. Okay. So this is what we need. So in that case, we can just go ahead and say that x plus 2 raised to power 3 is equal to, take the first coefficient, that's 1, then pick x, then pick the highest power 3, and then 2 will carry power 0. So don't forget, the first term carries the highest power and it reduces. The second term carries 0 and it increases until it reaches the highest power. Then the coefficients you can get from Pascal's triangle, at least from what we've learned so far. So the next thing you have, the next coefficient is 3, then carry the x. The power 3 now becomes 2 in this place, and 2 itself carries power 1. Because at any point in time, if you add 3 and if you add the two powers, it must give you the highest power 3. So 3 plus 0 is 3, 2 plus 1 is 3. Next term is 3. So put the 3, then x, the power of x was 1, was 2, now it will be 1. Then the power of 2, which was 1, become 2. Then we have one more term. So you have 1. Okay. Pick x. X here was 1, so the power becomes 0. And 2, which add power 2, becomes 3. So having done that, we can now break down all the terms. Okay. So this is 1 into x3 into 2 raised to power 0 is 1. Anything raised to power 0 is actually 1. Then plus 3 into x squared. 2 raised to power 1 is 2. Plus 3 into x raised to power 1, which is x, into 2 raised to power 2, which is 4. Plus 1. X raised to power 0 is 1. Okay, 2 raised to power 3 is 8. Then we can tidy things up. So we have x3, that's 1 times x3 times 1. That's x raised to power 3 plus 3 times 2, 6 x squared plus 3 times 4, 12x. And lastly, 1 times 1 times 8 plus 8. So what do we have? And say, therefore, x plus 2 raised to power 3 is equal to x cubed plus 6x squared plus 12x plus 8. Normally what you should have done is, what you should have done for this should have been x you should have done something like x plus 2 raised to power 3, and that will be x plus 2 into x plus 2 into x plus 2. And then you expand this, and then you later now multiply by this, which is going to take a lot of time, okay? But you don't have to worry about that because you can easily use Pascal's triangle to get the coefficients and go your way, right? So before I go, let me give one or two practice questions. Expand. So I'll just say expand. Practice questions. Practice questions. Expand using Pascal's triangle. Okay. First, let me say x minus 2y raised to power 5. Second, say a minus 1 over b raised to power 4. Okay. Then let me make it 3. Let's say 1 over x minus y over z raised to power say 6. Let's do it that way. So try your hands on this and see how well you can do this. All right. So if you have not subscribed to this channel, there's so much more coming your way. So you don't want to miss out on anyone. So subscribe to this channel, hit the notification bell, comment, let me know how helpful these videos are. Let me know if there's a topic you'd like me to teach or a problem you'd like me to solve. And like and share so that more and more people can have access to this great learning. Till I come your way again, keep doing maths right. Bye.